This week, we're going to be covering loops, iterables, and iterators, slides by Gaurav Nayak and presented by me. And thanks to Gaurav for taking the time to create these slides. It really helps me out. Cool. So loops. Loops allow certain portions of the code in your program to execute a number of times. This repeated execution of a set of statements is called iteration. So whenever we iterate over a certain iterable object, that's considered iteration when we're looping over that object. Loops enable iteration on Python objects that are capable of returning its members one at a time. So if we have a collection of objects, like we've seen in our data structures lectures so far, you can generally iterate over those objects and return the individual elements or members of those data structures one at a time, or operate on those members one at a time. So there are a couple different types of loops. There are for loops, while loops, and nested for loops. So just like we've seen with conditionals so far, you can nest loops within each other, and we'll see some examples of all of that as we go. So iterable objects in Python include arrays and lists, dictionaries, tuples, and strings. And there are some objects that aren't iterable. If you try to iterate over an object that's not iterable, you'll get an error saying that it's not an iterable object. So just keep that in mind. While a lot of data structures are iterable, not all are iterable. Cool. And then common functions that are used to loop include the range function. So the range function basically defines like a number of times that you want to loop over something, and we'll see how to use that later on in the lecture. And please, if you have any questions, I think it's worked really well in past lectures for everyone to just post your questions in the chat, and I will answer them as I'm able, basically at the end of the slides when it makes sense. Awesome. So to start out, we're going to go over a for loop. So a for loop iterates a list. You can iterate a list of objects using a for loop. So say we define this list of student names, as we saw in last week's lecture. This is a list. It has the square brackets. Everything is separated by a comma here, and this is a list of strings. Remember that lists can have multiple different data types within them, but in this case, we just have a list of strings. So we're defining our list, called student names list. And in that list, we have David, John, Simon, and Jack. And then down here, we're going to create our for loop. So the syntax for for loop, you start out with the for keyword, and then you give some sort of variable. So this is really considered like a for each loop. So you can consider it like for each student name in the student names list. Then we're going to do something with that student names list. So we're creating a variable here, and this variable's scope is basically only within this list. So or within this loop. So when we say for student name and student names list, then we can reference student name within the loop. And remember, just like with if statements and other conditionals, you want to have that tabbed underneath the for loop. So for student name in student names list, and then we have the colon at the end to end that for statement. And then within that for loop, we're just going to print out the student name. So on each iteration of the loop, it's just going to grab, one of the values within the list that we're iterating over. So this will print all the items in student names list one by one. So on the first iteration of the loop, we go in and we iterate. We're iterating over the list in the order that it's defined. So on the first iteration of the loop, we're going to grab David, and then and David is basically what's going to be assigned to the variable student name, the locally scoped variable student name, and then we're going to print out that student name. So we print out David here. Now on the next iteration of the loop, so that was the first iteration of the loop. Now on the next iteration of the loop, we're on John. John is what's assigned to the variable student name, so we print out John. And then the third iteration of the loop, we're going to be grabbing Simon, and Simon's what is temporarily assigned to student name. Since we're printing student name, we'll see Simon printed out here. And then finally on the last iteration of the loop, we'll grab Jack. Jack is what's going to be stored in the student name, and Jack will be printed out to the console. Now we've finished iterating over our list. There's nothing else to iterate in here. So since we were iterating in a for each sense. So we said like for each student name in student names list. Now that we're done with that list, we just end the execution of our for loop, and the code would continue executing down here if there were more code in our program. In this particular example here, there isn't more code to execute, but once we're done iterating this loop, we move on to the next lines of code. So if there are any questions on that, please add them to the chat, but otherwise I'm just going to keep moving along because I'm not seeing anything yet. So for loop continued. So something that's important to remember here is that strings are arrays of bytes. Remember how last week we had discussed how strings can actually be considered like lists of characters, basically. So you can iterate a string using a loop. So here we initialize our string. We're going to call it welcome message string, and we're going to assign to that hello to everyone. Then what we're going to do here is we're going to iterate over, basically this is like for each message character in welcome message string, oops, I clicked too early, do something. And in that line of code, or in the code that's going to execute as part of the for loop, we're just going to print the message character. So this will iterate and print every character, including the spaces, each on a new line. So on the first iteration of our loop, we get the first character of our welcome message string, because remember, we can consider this like a list here, and we print the H. The second iteration of the loop will print the E. The third iteration of the loop, we print the L, and so on, all the way down until we've printed that final exclamation point at the end of our string, and then we're good to go, and we'll exit the for loop. Yeah, so just keep in mind that you can iterate over strings like lists, because strings are basically like a list of characters. That's one way that you can think about them. Of course, not every list method can be used on a string, but it's definitely something worth keeping in mind. And it looks like we have a question in the chat. So should every item be defined individually in a list using a loop? So I'm not 100% sure I'm following, but I'm going to try my best to answer. And if I don't capture it, please just ask again, maybe in a different way. But so should every item be defined individually in a list using a loop? So not necessarily. It doesn't have to be a list. It can be any number of data structures. You could iterate over dictionaries. You can iterate over arrays. Lists are one of the most common things you're going to iterate over. But if you do need each thing within your list that you're iterating over, it does need to be previously defined in order for you to actually iterate over those elements. So we had to already define welcome message string, or in the previous slide, our list. So then when you're iterating over it, you're grabbing the individual elements of that list or string. So yeah, if you're referring to the list of names that I had previously given, yeah, these do need to be defined already before we do the iteration over that list. So we had to define student names list first and give it some number of elements here, and then we iterate over that loop. So that each iteration of the loop, we grab, student name on the first, David as the student name in the first iteration, John as the student name in the second iteration, Simon in the third iteration, and Jack in the fourth iteration. So this does need to be defined individually already. If we wanted to iterate over the individual like characters or something within these strings, then that's a nested for loop case. Yeah, so I hope that answers the question. If it didn't, please please try to let me know where I missed what you were getting at. Great. So I don't see any other questions in the chat yet, so I'm going to continue moving on. So now we're going to discuss while loops. So a while loop is used to execute a set of statements or iterate an object until a condition in the while statement is true. So if we have while condition, this condition here is going to be a Boolean expression. So just like we've seen in our conditional blocks before, any Boolean expression can go here, but what you want initially generally what you're going to want is that this condition should start out evaluating to true, and eventually it's going to evaluate to false. So yeah, the condition must be evaluated as true or false, and eventually you want it to evaluate to so you want it to start out as true generally, because while it's true, you're going to execute the code that's underneath the while loop. And then as soon as it evaluates to false, you'll exit that loop. So while conditions, some code, some operation that eventually turns the condition to false. So this is very important. Otherwise, the code will not stop. So this is a great way that you can crash your computer if you create a while loop that never ends. So if you don't have some way to make your condition false at some point, then your code is going to just keep looping forever and ever and ever and ever. And then you're going to end up with an infinite loop, is what that's called. And that's a great way to make your computer, use up all of its resources, just iterating over that loop, and eventually crash your computer. Especially if you don't have like a ton of RAM, or if you're doing a memory intensive operation inside of your loop. So in this particular case, we're going to create a list of fruits. So we have fruits are apple, grapes, bananas, oranges. We're going to create an index variable, and we're going to set that index variable to 0 for now. And this is kind of a case where we might be using a while loop in a way that might be better to use a for loop, but just for the sake of example, this is how you would use a while loop in that place. So now we're going to say while index is less than 4. So we're saying like basically while the index is less than the length of this list here, then we're going to print the value of fruits at that index. So now that we don't have, so with our for loops, we had this reference to like message character, like for each message character and welcome message statement. So we had something that we could reference within our loop that would correspond to the item that we're currently iterating over. With the while loop, we don't have that. So instead, we're going to have to index things, and we can use the index counter that we're using in this particular example. So we can print fruits at index, whatever the value of index is at the current moment. So on the first iteration of the loop, it's going to be 0. So we get apple on the second iteration of the loop. Because we have index equals index plus 1, we could have also had index plus equals 1 here, going all the way back to week 2 when we talked about the assignment operators. So on the first iteration of the loop, we go in, index is equal to 0. We check this condition. Is index less than 4? It is. 0 is less than 4, so that evaluates to true. So we enter into our loop and we start executing the code in here. We print fruits at index 0, so we print out apple, and then we take index and we add 1 to it and assign that back to index. Now the value of index is 1. So now we check our condition again. Is index less than 4? 1 is less than 4, so we print fruits at index 1. We're going to print grapes, and then we're going to increment index again. Now the value of index is 2. Check this condition again. 2 is less than 4. Yep, so let's go into the code. And we execute print fruits at index 2. We're going to print out bananas here, and then we're going to increment index again. Now the value of index is 3. Is 3 less than 4? It is. So we go in, print fruits at index 4. So we're going to, at index 3. And so we're going to output oranges to the console. We're going to increment index again. So now the value of index is 4. So now we check, is 4 less than 4? It's not. So this has evaluated to false. Now we exit our loop, and we're going to go on and execute code that comes after the loop. So this is a properly created loop where we are making sure that our properly created while loop where we're making sure that eventually our condition up here is going to evaluate to false. If we didn't include this line down here, the condition manipulator, then this loop would forever keep printing apple, because the value of index would never change. 0 would always be less than 4, and we'd always print fruits at index 0. So we just keep printing apple until our computer crashed, until we force quit the program, whatever might come first. So note, while it requires an index to iterate through the members of objects, note while requires an index to iterate through the members of an object, while a for loop doesn't. So a while loop requires an index here, as I had mentioned earlier, but a for loop doesn't require that because we could say like for fruit in fruits and then just print fruit on each iteration there. So keep that in mind. You're not going to have a reference to the element that you're currently iterating on when you're using a while loop. That's why in a case where you're iterating over a specific set or a specific collection of objects, it's better to use a for loop, whereas a while loop can be good for other conditions where you might have something that that Boolean expression is like non-deterministic and it's not based off of a certain number of iterations or something like that. Great. I'm not seeing any questions in the chat, so we'll just keep trucking along. All right, so nested loops. So it's possible to nest loops. You can have a for loop inside of another for loop, or a while loop inside of another while loop, or in the case down here, we have a for loop nested inside of our while loop. So in this particular case, we're going to start out with row count equal to 1. So while row count is less than or equal to 6, we are going to print the current row. So we print row count. And then for star in range, and this is the range function that we had talked about earlier. Range, you give a starting point and an ending point for your variable, or for the range that you're trying to iterate over. So this will basically return like a list of numbers from whatever the first value you enter to the second value you enter. So what we're doing, just to reiterate again, while row count is less than or equal to 6, print row and then the row count, and then for star in range 0 to whatever the row count is, we print that we print star, which is going to be that value, and then we're going to iterate row count. So we get row count equals row count plus 1, so that we make sure that we're eventually going to exit our while loop. So our outer loop is this while loop, and then our inner loop is the for loop. Notice that the for loop is indented inside of our while loop, and then the code that executes as part of the for loop is indented within that for loop. So this outputs row 0, or row 1, sorry. So what we do here is first row count is equal to 1. While row count is less than or equal to 1, we print row and then the row count. So we print row 1. And then for star in range 0 to row count. So for the value 0 to 1, and something I forgot to mention is that this row count is exclusive. So this value won't actually be printed here. Then we just print star. So we just print 0 there because only 0 is returned since we're going 0 to 1. And then we're going to increment row count. Now the value of row count is 2. So 2 is 2 less than or equal to 6. It is. So we print row count. We print row 2 here. And then for star in range 0 to 2, now we print 0 and 1 because on the first iteration of this for loop, the value of star is 0. And then on the second iteration of the loop, the value of star is 1. And then we're going to exit that loop. And then we're just going to keep going since we then increment row count again. Now row count is 3. 3 is less than or equal to 6. So we enter this here and then we output our row count, row 3. And then we, for each star in range 0 to 3, we're going to iterate over this. So we'll print out 0 on the first iteration, 1 on the second iteration, and 2 on the third iteration. And then we're going to keep looping. So I'm not going to go through all of this, but this just shows you can kind of look at the output here with this code, and this is exactly what you would get. So let's see, there's a question here. Is there a typo on the first line of print? So no, actually, this is just a different, that's a great question. This is just a different way that you can use the print function. One way that you can use the print function is just doing like, a string value, comma, the row count that you're outputting. So this works. This is just something we haven't talked about before. One of the reasons we hadn't talked about it before is because I wanted you all to get experience with the concatenation operator, because it's important to know how to use that plus operator to add two strings together. But in this particular case, this is just another way that you can print things out. So you would, it prints the first thing followed by the second thing added into the print function. Great question. But that's not a typo. That's a perfectly acceptable way to do it. Sometimes it can be less readable or confusing, but it's totally valid code. All right, so where are we getting the star from? Great question. So here, that's from our for loop. Remember that with a for loop, you're saying like for star in this collection here. So this is an iterable here. The range function returns an iterable object. And so this returns an iterable collection from 0 to whatever this value is, excluding whatever this value is. So star is now like a locally scoped variable that's only available within the for loop. So this basically creates, this is like, saying for each star or each number, could be another way to think of it, in what's returned by this range function, print that the value of star at that current iteration of the loop. So on the first iteration of the for loop, say that row count is 3. So the range is going to return 0, 1, and 2. Range 0 to 3 is going to return the values 0, 1, and 2 as a collection. And then so we're iterating for each value in that collection. On the first iteration, star is assigned the value 0, since that's the first value in the collection returned by range. So we're going to print 0. And then on the second iteration, now star is going to be assigned the value 1, because it's the second value in the collection returned by range. And then we're going to print 1. And then on the last iteration, because it's the last element in the collection returned by range, we're going to assign the value 2 to star. And then here we're going to print star. Something important to note is that star is not going to be available outside of this for loop. So if we tried to reference it on the same line where we have row count right here, we're going to get an error because it's only scoped. It's the scope of that variable is only within the for loop itself. So star is a completely arbitrary name for that variable there. We could have said for number, for value, whatever we might want to add. It's completely arbitrary. So star is just, what was chosen by the developer in this particular case. So I hope that helps clarify where star came from and its values. If it didn't, please ask any follow-up questions and I'll be happy to answer. But thank you so much for the questions so far. These are great. All right, let's move on. Oh, and one other thing I want to note here is that every time you see row 1, that's like an execution of the outer loop here, and then anytime you see just a number, that's like iterations of the for loop. So you'll see row 1 and then you print 0, and then row 2 and then you print 0 and 1, and then row 3 and then it prints 0, 1, 2. So row 3 is what's executing as part of the outer while loop. And then of course, all of this is executing as part of the outer while loop, but what's really making, multiple values output there is the for loop in there, because, the for loop only executes as part of the while loop. As soon as row count, or as soon as this Boolean expression evaluates to false, so when row count hits 7 and this evaluates to false, we're not going to execute the for loop inside there because its scope, the scope of the for loop is only within the while loop. Great. So if I'm not seeing any other questions in the chat, so I'm going to keep moving along. But if there are any, please keep adding them to the chat. This is great. All right, so iterable functions. So range returns a collection of numbers. So the syntax, as we already kind of alluded to on the previous slide, it accepts 3 arguments: the start, the stop, and the step. So the first argument of start is optional. The second argument of stop is mandatory. So you have to provide at least one value here. And remember, the stop value is exclusive. More on that here in a second when I go over the examples over here. And the step is optional. The value there, it defaults to 1. So that basically means like, what value do you want? How many, or what's the size of the step you want to take on each iteration in a way of the returned value of range. And we'll talk about that in the example over here. So for this one first here, all we're including is the mandatory stop argument. So for I in range 5, this is acceptable to have the space here. It might be a little more readable to remove that space, but it is acceptable to have these spaces between the function and then the parentheses that follow it. But just to note, it is a little more readable if those aren't included. So for I in range 5, remember 5 is exclusive, but we're going to print out each I in that range. So this is going to return a collection of values 0, 1, 2, 3, and 4. because that 5 is exclusive, so we don't see a 5 output down here. And then on each iteration of the loop, we're just going to print out the current value of I. So on the first iteration, I is equal to 0. So we print 0. Second iteration equal to 1. Third iteration equal to 2. Fourth iteration equal to 3. And fifth iteration equal to 5. So the default of start is going to be 0. So that's why we started out with 0 here, but remember that the stop argument is exclusive. So we won't see a 5 output in this particular case. Now, if we do include 2 arguments here where we have for I in range 1 to 4, now our starting point is 1. The 4 is still exclusive, so we're not going to see a 4 out here, but on each iteration of the loop, the first iteration of the loop, we take the starting value, which is 1, and we print that out. Second iteration, 2, third iteration, 3, and then we don't output 4 because this is exclusive. I'm just going to keep repeating that because it is important to note the stop is exclusive. So if you wanted to print 4, then you would want to have your stop be 5. Just something important to keep in mind. Oops. And then for this last one, for I in range 1, 8, 2. So we're setting 1 as our starting point. Our stopping point is going to be 8, again, exclusive, and our step is going to be 2. So on the first iteration of the loop, we use our starting value, which is 1, and that's what's going to be output here. But on the second iteration of the loop, now we increment by 2. So now the value of I is going to be 3. So we're going to see 3 output to the console here. Now in our third iteration of the loop, we incremented again by 2. And now the value of I is going to be 5. So we see 5 output to the console. And then finally so that's 1, 2, 3, fourth iteration of the loop, we're going to increment it again by 2. So previously it was 5. Now we're up to 7. So the output we're going to get is 7. We never see 8, first off, because it never would have been evaluated in this particular case, because what we're actually doing here is printing out all odd numbers. So 8 would never have been output, but even if this value was 9 here, we would never have seen 9 output to the console here, because remember, the stopping point is exclusive. So great. Not seeing any questions in the chat. I know this is a lot to, oh, there's one. Could you please use your program with an example using a step? Yeah, so please remind me at the end to go over that. I'll show an example, a live example of using range with step. So please remember to circle back on that at the end of lecture when we're done going over all of the slides. So iterable functions continued. There are a number of other functions and methods that you can use to iterate over. So the .keys method. Remember when we had talked about dictionaries, one of the methods on dictionaries was the keys method. Same goes with values and iter keys and items. All of these are things that you can use for iterating over a dictionary. So if you want to iterate over the keys of a dictionary, you can take your dictionary dot keys, and that'll return all the keys, and then you can iterate over those keys. If you wanted to iterate over the values, you can do that. Iter keys is kind of like iterating over the keys, and then items will actually return like tuples of your values. So this would be iterating over the key value pairs of your dictionary when you use the items method in your iterable. So enumerate can convert a list into an iterable list of tuples. We're not going to spend too much time on enumerate or iter. It's just, they're in the book. Please read about them. You might see them, but they aren't the most common things that people use. Yeah, so what enumerate will essentially do is it'll give like the index and the value at that index in the form of a tuple. So, going back to tuples from the data structures lectures. Iter, you can use iter to iterate through lists, arrays, strings, etc. So again, it's often easier to just use the list or array or string itself to iterate over it, but just keep in mind you can use the iter function if you want. There's a ton of other ways that you can use iterable functions to iterate over things, and we'll talk more about that and you can see more examples of that, in the book. But what's really most important to know is the ways that you can iterate over a dictionary, that you can iterate over a list natively, or if you need the indexes for whatever reason, you can use enumerate, and iter is another thing you can use for iterating over iterable objects. All right, so whenever it comes to any loop, the break statement is a super useful thing to know. So the break statement in Python terminates the current loop and resumes the execution at the next statement. So in this case, we're creating a list of items. Our list of items contains orange, banana, toys, and grapes. We're gonna have our for loop here for item in items. If toys is the item, basically, if the item's value is toys, then we're going to print I found toys in a list of fruits, breaking. We break outside of the loop, and then we would come down to this line of code here. So basically, on the first iteration of the loop, we have oranges. So the value of item is orange. So then we check if toys equals item. It doesn't, because item is orange, so this evaluates to false. We never enter this if block here, so we're going to print inside the loop and then the value of the item, which is orange. So we see inside loop orange. Second iteration of the loop, the value of item is now assigned banana. So we check this if statement, toys equals banana. That evaluates to false. We never enter the if statement, so we come down to this line of code, inside loop banana. So that's where we get this line of code here. Now, third iteration of the loop, the value of item is toys. So now we're going to check toys equals item. So toys equals toys, basically. This evaluates to true. So we go inside of the if statement and we print, I found toys in a list of fruits, breaking, and then we're going to break. And now we just come outside of the loop and so you say, I found toys in list of fruits, breaking, and now I'm out of the loop. So now you don't execute this line of code here because we broke before it. So we broke the loop and we come down to this line of code, and we never see anything output from grapes because we broke out of the loop when we were iterating on toys. So this is a super useful thing to know. This is something that often people will use with while loops because, in certain cases, you just want to keep iterating until some condition or until something is found, right? So in that particular case, maybe it's better to just use a break statement instead of some condition in your while loop. So you might just create a almost infinite loop by saying while true, so that it'll always keep executing until you find some condition inside of your code, and then you use the break statement to get out of it in a while loop. So super useful, especially when you're searching for something inside of a collection, or you're waiting for a very specific condition to occur. Then you can use the break to exit that loop. So if, say you're in this particular case, we're basically looking for toys inside of our list of items. Once we find toys, we break out of our loop and we just stop iterating over that list. Yeah, so I'm not seeing any other questions in the chat. So I'm just going to keep moving along. But yeah, break statement is super useful for terminating your loop early, basically. Oh, here's a question. If the value is false, there's not need to execute under if and go to break. So yeah, if this Boolean expression evaluates to false, then we never execute the code underneath the if, and so we never reach the break. The only time we would reach the break in this particular case is if this Boolean expression evaluates to true, which only once we reach the toys element in our items list do we actually reach this line of code and print I found toys in list of fruits, breaking, and then we actually reach the line break. But until this evaluates to true, we never execute the code inside the if. Great question. Cool. Not seeing any others right now, so I'll move on to the continue statement. So the continue statement in Python is used to skip the rest of the code inside a loop only for the current iteration. Loop doesn't terminate, but it continues to the next iteration. So now in this case, what we've done is we're taking this code and we have the same logic here. The only difference is we've replaced break with continue. So now what you'll notice is that we print inside loop toys because we did get to this line of code. So we do eventually, we didn't print inside loop toys because we didn't get to this line of code for the toys iteration because we continued here to the next iteration of the loop. but we do see inside loop grapes because we continued to the next iteration of the loop. We didn't break out of our loop early. We just basically didn't execute this line of code. So in this particular case, first iteration, orange, this evaluates to false. So we just skip down to print inside loop orange. Then we have banana on our second iteration. This evaluates to false. So we come down to here and we print inside loop banana. But now with toys on our third iteration, so item is assigned the value toys. So this evaluates to true. So we say I found toys in list of fruits, continuing, and then we continue. What continue does is it just goes to the next iteration of the loop. Instead of coming down and executing this line of code, we skip whatever is remaining in the for loop and we come to the next iteration. So now we have grapes for item. This evaluates to false. So we print inside loop grapes. Now we've reached the end of our iterable list here, and we're going to output I am out of the loop. So continue is great for situations where you have a certain, if there's a certain value in your collection that you don't want to do the subsequent operations on, then continue is great for that. But you still want to continue doing those operations on the rest of the items in your list. So break is great for when you're, say, searching for something, and once you found it, you want to end the execution of your loop. Continue is great for, I have this thing that I don't want to do this particular operation with, or these subsequent operations with, so let's just continue to the next iteration of the loop instead of executing the rest of the code within that iteration of the loop. Cool, checking if there are any other questions. Yep, not seeing any questions, but yeah. So hopefully that distinction is clear between continue and break. Break ends your loop early, and yeah, ends your loop early before it's done looping over everything. Continue just goes to the next iteration of the loop. Oh, there is a question. Continue statement is incremental statement, i.e. whether true or false. So not necessarily. So we could theoretically have, for item and items, and if we just put a continue statement right at the top right here, before the if toys equals item, we would just never execute any of the rest of the code here. We would never see anything output to the console. You can have continue wherever you want. It doesn't have to be in a conditional statement. Like is the case here. It's generally a good idea to have it as part of a conditional statement, because if we just had it at the top here, then what are we even doing in this loop, right? If we just had it at the very top, before if toys equals item, if we just, had continue right there, what's the point in having the rest of this code? The rest of this code will never be evaluated. So while it's not required to have it in a conditional, it's generally best practice to have that in a conditional. Yeah. Great question. I hope that helps clarify things a little bit. Yeah, keep the questions coming. These are all great. In the meantime, since I'm not seeing any others, I'm going to move to the next slide. Oh, okay, cool. So we're basically at the end of this lecture. So again, some resources, and whoever's drawing on the screen, if you could please stop doing that. I'm going to stop sharing my screen so that I can get rid of that. And now I'm going to reshare again. All right. Yep. Cool. So additional resources here. If you want to learn more about for loops, I can't say it enough. W3 Schools is an excellent resource for Python, especially introduction to Python stuff. So we have a link here for Python for loops, and then a link here for Python while loops, and there are exercises for each of those at the bottom of the page. Seriously, like if you're struggling with anything in the course, please go to W3 Schools, take some time to read that stuff and do the exercises. It only stands to benefit you. Practice is the best way to get better with programming. So while I'm happy to answer questions when you have questions for me. Often it's better to just get that immediate feedback when you do something wrong or right with using W3 Schools. So I can't encourage it enough. Please use W3 Schools, read through their resources, look at their examples, and give the exercises a try. It only stands to benefit you. Great. I'm not seeing any other questions in the chat. Let's go over the assignment really fast for the week, and then I'll do that example using STEP that was requested earlier in lecture. All right, so This week, the assignment is on loops, of course. So we're going to keep it kind of similar to what we had last week, where we have like distinct questions instead of, a whole scenario. So in this particular case, for question 1, I want you to write a program that accepts a number. And one thing I want to note here is that Gaurav also helped out with this assignment. So thanks again to Gaurav for his efforts in writing the assignment. So for question 1, write a program that accepts a number and outputs valid if it is 5 numbers long. So for example 1, we give the number 1, 2, 3, 4. The response there should say that this is invalid because that is not 5 characters long or 5 numbers long. That is 4 numbers long. So remember it is important to note that this should be a number that it accepts. So hint here, you might need to cast it to a string when you're going to iterate over it, but it should accept a number. It shouldn't be a string to start out or anything. It needs to be a numeric value. Cool. So this one would output on example 1, it would output invalid. So for example 2, then we have 4, 5, 3, 2, 1. So this is 5 numbers long, 1, 2, 3, 4, 5. So the response that we would get there is it's valid for processing. So basically the expectation here is that you're going to take a number and you're going to iterate over it and determine if it's 5 characters long or 5 numbers long. If it's shorter than 5 numbers long, then we want to output invalid. If it's longer than 5 numbers long, we also want to output invalid. Only when it's exactly 5 numbers long do we output valid for processing. So question 2, modify the program in question 1 that adds all the digits of the entered number and display it in the form of an equation using loops. So for example, say we have 5, 6, 7, 8, 1. So, since it's modifying what you did in question 1, we want to have 5, 6, 7, 8, 1. We check first, is that 5 numbers long? It is. So we're going to output valid for processing. And then what we want to output after that is 5 plus 6 plus 7 plus 8 plus 1 equals 27. So you're actually going to do the math there, but we also want to see you output the equation here. So a little hint there on how that might work using a loop. You're going to want to use the concatenation operator to build a string, which is you're going to, like, on each iteration of the loop, keep building out your string based off of the value at that current iteration of the loop. So note the left-hand side of the answer must be dynamic. So this should be dynamic. What we don't want to see is some value hard-coded that's just 5 plus 6 plus 7 plus 8 plus 1 equals 27. We don't want this hard-coded. We want it to be like if we did 4, 5, 3, 2, 1 as the input, we would want to see 5 or 4 plus 5 plus 3 plus 2 plus 1 equals whatever that adds up to. Let's see, that's 5, 9, 10, or let's see, 5, 9, 12, 14, 15. So we would want to see 15 output there. So just make sure that that it's dynamic. We don't want to see any hard coding of the values here. So question 3, modify that program that you had written in question 1 and 2 and capture the below scenarios. If there is a number 2 in the entered number, then do not add it. So we still want to make sure that the value is 5 characters long or is 5 numbers long. This is, so 7, 3, 2, 5, 1 is 5 numbers long. But now what we want to do is we only want to add up 7 plus 3 plus 5 plus 1 because we want to ignore the 2 that's in there. And then we're going to get 16 as that answer there. And then for the second part of question 3, if there is a number 9 in the entered number, then multiply that number by 2 before adding it. So if we have 1, 2, 9, 4, 9, then we'd add 1 plus 2 plus 18 because we found a 9. We multiply that by 2, so we add an 18. Plus 4 plus 9, we have another 9 there, so we multiply that by 2 and add it, so we're adding another 18, and we get 43. So notice how we multiplied 9 with 2 different times. So both times that 9 occurred, we multiplied it by 2 and added that to the number. So these are distinct answers here, because notice in this one here, there was a 2, but we didn't ignore that 2. So, make sure that to have like 2 different sections of your code, that one of them removes the 2 and doesn't include it, but doesn't double the 9, and then another one that doesn't remove the 2 but does double the 9 if it's present. And keep in mind that if there's not a 9 in there, we don't do any like doubling anything in this particular case. Again, this should be entirely dynamic. So just because in this case the 9 happens to come as the third digit and the fifth digit, that doesn't mean it's always going to be the case. The 9 could be the first digit, the second digit, or 9 may not exist in your number at all. Just make sure everything is completely dynamic, so that whatever number is entered, the answer that we get here is reflective of whatever the number is that I enter myself. Great. Any questions on the assignment before I move on to demo? All right, I'm not seeing anything in the chat, so I'm gonna pull over PyCharm so we can go over some demos here. So the demo that we wanted to see was use the program with an example using a step. So let's say we want to do for num in, so num is just like number, num in range. Let's say we want it to go up to 10. So this is the stop value. We're going up to 10, and then the step is going to be, but we're gonna start at 0. We're gonna go up to 10, and then we're going to as our step, let's say our step is 2. Now we want to print the value of number, or the value of num. So on this loop, on the first iteration, the value is going to be 0, so we're going to print 0. The second iteration, though, since our step is 2, we're going to increment by 2. So on the second iteration, it's going to output 2, not 1, because we started out at 0, increment it by 2, so we're going to output 2. Then on the third iteration, we're going to output 4, and so on. So let's just see this run. So see, we started out with 0, increment it by 2, and then we output 2. And then we increment that by 2 again. So we get 4, we're going to output that. Increment it by 2 again, we get 6, output that. Increment it by 2 again, we get 8, output that. Remember that the stop is exclusive, so we never saw the 10 here. So we never actually print out 10. If I wanted to print 10, I can modify my loop to have a stop of 11 or any value greater than 10, really. And now we'll see the 10 because the stop was 11. So we kept evaluating at 10. So our step could be any value. So say, let's increment this to 12. And let's say we want to only print multiples of 4 or something. We can set our step to 4. And now we're just going to get 0, 4, and 8. Even though 12 is a multiple of 4, we didn't output that because our stop is 12. And remember that our stop is exclusive. So if we wanted to include 12 there, we could instead, increment this to say 13 as our stop, then that will output 12. So first iteration, we started out with 0. Second iteration, we incremented that value by 4. Third iteration, increment that value by 4, and we get 8. Increment by 4 again, we get 12, and so on. So hopefully that's helpful to see all that. So another question in the chat: which materials will help us with the assignment? Q3 and 4 don't look user friendly. So all of the materials that we have in the course so far are going to help you. So all of the materials that we've learned in the course so far are going to help you with the assignment. I know it may not seem like it, but we have learned everything that you need to know for all of this. So what I'd recommend is checking out, reviewing loops, review casting your integer number to your integer number to a string, so that you can then iterate over it with a loop. Review string concatenation. String concatenation, remember the plus operator works as a concatenation operator when using it with a string. So just for a quick example of that, if we had hello plus world, that puts it together into hello world. Remember, the plus sign can be used as a concatenation operator, remembering all the way back to lecture 2 on that. So All of those things are going to be used in all this. You're going to need a conditional as well for 3, because you're going to want to check if the current number you're evaluating is a 2 or a 9 for each of these scenarios. And then yeah, so it's going to use a lot of what we've learned so far. That's the point of this assignment. Make sure that you're constantly building and constantly reusing a lot of things. But we have reviewed everything that should be required for this assignment. If you have any questions on it, please let me know. I'm happy to answer any questions. But please do review, just to put that in a finite list again. You're going to want to review casting an integer to a string. You're going to want to review loops, which is what we went over this week. You're going to want to review conditionals for checking if the current value that you're working with is one of the ones that you want to ignore. And then you're going to want to review string concatenation, because you're going to have to build out this string by concatenating all of these things together. So hope that helps. So remind us how you set the stop value. Yeah, so the stop value, recall, for the range function, stop value is, so the first one here is start, the second one is stop, the third one is step. So whatever value you put here is going to be your stop value. And remember, it's exclusive. So just going to keep repeating that over and over again. I know it might sound like I'm kind of beating a dead horse there, but yeah, stop value is exclusive. But this is how you set it. You can also, if we wanted, we could have for num in range. Remember that if you only include one argument, that's just going to be your stop. So if I just say 10 here and then print 10, oops, not 10. I don't want to print 10. I want to print my number. So print num. Now that's our stopping value. If we give range 2 arguments, now start is the first argument. So let's say we wanted to, for whatever reason, start this at 2. So we start at 2. Now we'll start at 2 and go up to 10. But remember, 10 is exclusive, so we're not going to see the 10 output there. But we started at 2. And then if we add a third argument, that's going to be our step. The default is 1. So if I just add 1 here, we're going to see the same output we saw above. But if we wanted to increment by, say, 2 on each iteration of this loop, then I can set my step to 2. If for whatever reason we wanted to increment by 3, we can set our step to 3, and now it'll go 2, 5, 8. So hope that helps. So another question regarding the statement in one of the assignment that says if 2 is not in the range, it shouldn't add. Are we going to add that in the print statement? 2 is not in the range, don't add. You totally can. That's an excellent question. It's not required for the assignment, but I think that's a great thing to add just for your own verification that it's working, right? Really, what I'm looking for with these assignments is that you just meet the minimum requirements of these assignments. As long as your code functions as the assignment specifies, whatever other logging you want to put in there, and that's kind of what putting in statements like 2 is not in the range, don't add. That's kind of like a logging statement. It's something that's going to be useful to a human going through and trying to debug. Use them. I am all about it. That's totally fine. If you add extra print statements into your code, I'm not going to say that's a bad thing. That can definitely help. So go for it if you want to, but it's not required for the assignment. Great question. Any other questions that I can go over here? Step is like climbing stairs to by from a certain stage to before stop according to the example. Yep, yeah, exactly. So you can think of, that's a great way to think of it. I like it. Step can be going by, step can be like you're going up a stairs and you're saying how many steps to take in each individual ascent, I guess, of that staircase. So yeah, it's like saying, start on step 2, like of our staircase, start on step number 2, and each time you go up the stairs, skip, do 3 steps in each of your individual foot placements up the staircase. So yeah, that's a great way to think about it. Stop is like, you know, you're not going to ever go to that top step in a way because it's exclusive. So you will, yeah, you'll stop before the value of stop. Yeah, so this is like, if we do this one here, say we're climbing a staircase that has, you know, 9 stairs, then this is how you would climb that staircase of 9 stairs if you started at step 2 on that staircase. So yeah, I really like that way of thinking about it. It's like climbing stairs 2 at a time from a certain stage to whatever the value of stop is. One of the reasons, and this might be helpful as well, one of the reasons that 10 is exclusive there is often what people are doing with range is they're iterating over like something that has indexes, right? So say, and I'm going to show you something interesting here, but say we have my name, let's just call it name equals David. So this is my name. So if I wanted to create for char in range, or let's do I, because that, like, I will be indexed. So for I in range len, so len is a way that you can get a length of a string name. Why did that go away from there? There we go. So now we're saying for I in range len name. So what this is going to do is it returns, you know, our original starting point is 0, and then it's going to go up to whatever that len function returns. Len is how its length, so you can think of it as length. So I'm getting the length of this string. That's 0, 1, 2, or 1, 2, 3, 4, 5 characters. So we're saying for I in range 5, basically there, and then I maybe print name at index I. So now what this does is it outputs the whole David, right? Because of indexing here. So that's one of the reasons that range starts at 0 and is exclusive on the last value, because it's kind of like when you're indexing anything. Because remember, in Python, a list or a string, everything's 0 indexed. So when you have so range returns 0 as the first one, it excludes the last one. So while my string David is 5 characters long, the index of the last character there is actually index 4. So that's why range will return, you know, 0 through 4 instead of the 5 that's added there. So hopefully that wasn't just more confusing than beneficial. I find it useful to think of the way range behaves as like returning index values in that in like a collection that's that many elements long. So helpful to me. If it's not helpful to you, don't worry about it. Just ignore that. But hopefully it is a little bit helpful to you. Any other questions on the assignment, what we've gone over today? All right, great. Well, with that, I guess we'll actually end on time for once. Sorry, I usually go over, but I'm glad we were able to get everything in the hour allotted today. So if there are any questions on any of this, please feel free to post it to the YouTube video, which I'll be uploading and sending out, or email myself, Braj, and Gaurav. Just a quick note, whenever you're submitting assignments or asking any questions, please send it to all myself, Braj, and Gaurav. You know, we all have a lot going on in our lives, like vacations or family or work, school, whatever it might be. So we're not all going to be available to respond at every moment. So it helps when you can ask all of us or submit to all of us. Then we'll each, you know, we'll get to it as soon as we're able. And when you're, you know, spreading it around to all 3 of us, there's a lot higher chance that you're going to get a little bit faster of a response instead of just waiting on whenever I'm available or whenever Braj is available or whenever Gaurav is available. So yeah. But thank you everybody for your time today. I hope you all have a great rest of your week. And I will talk to you all next Saturday. So I will upload this to you, the lecture to YouTube. I will share the link as well as the slides and the assignment with you all here shortly. But yeah, have a great rest of your weekend and an awesome upcoming week. I'll talk to you next week. Thanks.